this is the option astrophysics. We'll start off with objects in the universe. This is a short introduction. We're going to look at planets, comets, and the sun first. Planets. Now, initially, the Greeks thought these were stars, but were wandering around. They called them wandering stars, or planets in Greek. So these planets orbiting the star were formed around the same time and were basically made of the same pre-stellar material, which is basically mostly 90% of that is going to be hydrogen and roughly 9% is going to be helium. So that's what the planets were made of. However, the smaller planets, when they were made, were close to the sun and they were very small, which means that a lot of the hydrogen and the helium it wasn't able to retain. The formation of the sun made it very warm, the gases evaporated, and also the gravitational strength wasn't strong enough to retain these very light gases. However, planets that were further away, which were more massive and cooler, were able to retain the hydrogen and helium. So that explains why we have a very different chemical makeup of compared to the larger planets and also the sun. If we look at the atmospheres, for example, the atmosphere of Jupiter, Saturn, Uranus and Neptune are mostly hydrogen, as is the sun, followed by helium, as is the sun, and then you have other elements as well. The Earth and these smaller planets, these rocky planets, terrestrial planets, do not have hydrogen and helium. But Mars has a heavy gas atmosphere, which is carbon dioxide. We have nitrogen with some oxygen. Venus has lots of carbon dioxide and nitrogen, and so on. Mercury has a very thin atmosphere with some oxygen, and so on. The interesting thing about the solar system is the distances between the planets. If we do this roughly, between the Sun and the Mercury, we've got roughly 50 million kilometers. Then there's another 50 million to Venus. Then there's roughly another 50 million to Earth. Then roughly another 50 million to Mars. So these planets are fairly equally spaced out with 50 million between them. Then you go from Mars, which is around 200 million, to Jupiter, which is almost 4 times as far away. Then from Jupiter, Saturn, which is double that distance again. From Saturn to Uranus, which is double that. Uranus to Neptune is double that, and so on. So you see that as you move out, the distances start to get much bigger, and there's a lot of space between these planets as you move further out. Here's Mercury and Venus. Mercury is a very rocky planet. The Venus has got this very heavy carbon dioxide atmosphere with much a great deal of sulfuric acid in the atmosphere, a very unpleasant place to be. The Earth, we've been on this planet for hundreds of thousands of years, and so we're perfectly adapted for the Earth. There's no place like the Earth, really. The Earth doesn't have much hydrogen and helium as it ought to, because it was all blown away, it's all evaporated. So these are the materials that we have on the Earth. It's rocky. We have compounds of iron and oxygen and silicon and so on. Mars looks a bit like a scene in a western, very lots of desert. This is Olympus Mons, which is a huge mountain, much bigger than anything we have on the Earth. This is Olympus Mons compared to the Himalayas here. And this is the size of Olympus Mons compared to Spain, as seen from above. Then after Mars we have the asteroid belt, which goes from the orbit of Mars out to the orbit of Jupiter. And we have these very small minor planets. Then Jupiter, which is the biggest planet in our solar system, with this famous red spot. 4 very famous moons, Io, Europa, Ganymede and Callisto. This is the Earth compared to the size of Jupiter. You can see the atmosphere of Jupiter there's a lot of cloud disturbance there. Much of the atmosphere is moving this way, and some is moving to the left. So there's lots of wind disturbance there. Saturn also is a giant gas, famous for its rings, which are a layer of broken rocks which are in orbit around the planet. Uranus also is a gaseous planet, and the same for Neptune. Notice that the atmosphere, mostly hydrogen, helium, some methane as well, but notice the abundance of hydrogen and helium in their atmospheres and not in ours. We also have comets. Comets are like small rocky things, which the rock will be made of iron compounds and silicon compounds and so on, surrounded by water, ice, frozen carbon dioxide, which is like dry ice, also methane and ammonia. The nucleus itself is just a few miles across. When you see the comet, you see these giant tails. You've got one tail which is right opposite the direction of the sun. The solar wind pushes these, gives it this shape. Then also, if the comet is moving down, you would get another tail, which is a dust tail behind it. So comets often have two tails. One is because of the path that it's taken. One is because of the solar wind. Then we have the sun. The sun is the huge thing whose nuclear reaction basically gives heat to everything in the solar system. The mass is around 10 to the 30 kilograms. Then the surface temperature is around 6,000 Kelvin. Notice that the atmosphere is mostly hydrogen, 90%, helium around 9%, and then we have lots of oxygen and carbon and so on. These are important. When we look at the aging of stars, you'll see why we have this abundance of these elements.